So first is addressing mode. So in 8086, it is very rich by types of addressing mode. We have different 5 types of addressing modes. How many? 5. Okay. Implied addressing mode. First is implied addressing mode. Addressing mode. Then next one is immediate addressing mode. Addressing mode. Okay. Then next is a register addressing mode, and then after we have direct memory addressing mode. Okay, and the last one and very effective one is indirect memory addressing mode. Indirect memory addressing mode. Okay, so we are having different 5 types of addressing modes. So what does it mean by implied mode? Implied in the sense we are not going for use of any register. Okay, no register is used. It describes its meaning by its instruction itself, like CLC, clear carry flag. Okay, say STD, set direction flag. Okay, so such kind of instruction, they are describing that purpose. Okay, we don't need to use any other operand or operators or registers in this. So this kind of instruction or modes are known as implied mode. Okay, this is very basic or initial one. Then we have immediate mode. So immediate mode, we are using immediate value, or we are storing immediate value in a register. Say move, we want to store some value in particular, say we have register CX or AX. So I want to store value 2137. H in the sense this particular is hexadecimal value. Okay, so here we are storing whenever your register is followed by a value immediately, it is known as a immediate addressing mode. Understand? You just have to give one example for one addressing mode. Okay, just describe it and then give one example. Then what is register addressing mode? In register addressing mode, we are dealing with only registers like move, AX, BX. See, if we are dealing with 8-bit information, then we can write like AH, comma, BH, anything. Okay. So in register addressing mode, there isn't any value. We are just dealing with the register. Okay. So we can use any of 4 register according to the purpose. Okay. In this case, we can use AH or BH for mathematical, say mathematical operation. Then direct addressing mode. Direct addressing mode in the sense, say this is very faster one. This particular is faster. Why? Because we are this values are initially stored in a register. So register are part or component of your processor. Okay, if you are dealing with any value, then value would be provided by any input device. Okay, it would be display on output device but provided by input device. So it would take a time, but this one is register to register within the processor, so it is faster one. Okay, then addressing mode, direct addressing mode. So here we are providing the memory address. Okay, and you have to remember we have a one more use of square bracket. Suppose there is any destination, so we are interested in string operation, so for that we have to use dx register first and some values. So here I can write like this, any particular memory address, say 2000. Okay, So if you are interested to store or you are interested to move values stored at the 2000 address, see the square bracket indicates it is address. So it address 2000, whatever is stored will move to dx register. Okay, so this is direct addressing mode. In this direct addressing mode, you should know what is your address value is. Okay, if we don't know the address, then or is it possible to recall address all time? Of course not. So we have one more option, or the most powerful option, that is indirect addressing mode. In indirect addressing mode, we have to share or the same instruction, but here it is dx comma, it would be something like this, bx. So first, what we are supposed to do, we have to store this bx into this 2000 into bx. There would be one more statement over here. We can write like this, move bx comma h. Okay, so now 2000 is stored into bx, so we don't need to recall address all time. Or suppose you have a more than one registers, then it would be difficult to recall the memory address. So here we can store into the register, so we can use it. Okay, so these are the different 5 types of addressing mode. Here actually we are dealing with most powerful addressing mode, just because it is there is use of memory address, and that address is also stored in some other register, stored at the another register. We can say this is kind of pointer. Okay, this is our pointer variable which is addressing address for particular value. Okay, so it is kind of the indirect memory addressing mode is kind of pointer variable. Okay, so this is most powerful and strong one, because no information is displayed over here, which address and which information. Okay, and we don't need to mark up the address even. Fine. Now if you want, I will go through this pin diagram, because it is not that important, but maybe ask or maybe not. So if you want, I will go through it, otherwise not. You can write me in chat board. Are you interested to go for a pin diagram? Addressing mode is just to provide the operand and its data. How using the different ways we can provide data to address our required register. Okay, so we have different 5 ways to provide data to a particular register. So this particular is very rich in terms of addressing mode. Okay, now let us go through this addressing mode. First, see whether you know about this structure of pin or not, but you must recall the use of pin. Okay, especially ALE, address latch enable. So whether it would be address, if it is high, then it will deal as a address bus. Which bus? ALE, address high, address latch enable. So whether a few pins would work as data bus or address bus, or data bus. Okay, so it is up to ALE. Then mean and max. So this pin will decide whether your processor is in minimum mode or maximum mode. Okay, then memory and IO. So with whether you are taking, are you accessing the values? If it is 1, that means you are dealing with memory. Whatever value you have is catch from memory. You get values using memory. Or as if it is 0, then processor is dealing, or it is it has taken values from IO. Okay, So first is, if first option, that is 1, m equals to 1, and if it is 0, then second option. If you remember our ternary operator, if condition is true, then first option. So condition true in the sense, if first is 1, then you have to go for it. If it is 1, then memory is used. If it is 0, then IO device is used to get information. Okay. If it is 1, then M would be there, or it can say that it is in a minimum mode. And if logic is 0, if it is 0, then minimum, and 1, then maximum. Then similar way, we have one more pin, that is interrupt NMI, and there is combination of two, NMI, and we have another set of combination, that is interrupt IN, interrupt respond, and interrupt acknowledgement. This is a bar 1, INT, interrupt acknowledgement. So here we have a bar on this statement. Bar in the sense it would active at the 0 value. Interrupt enable. So these are few important. Interrupt NMI is interrupt, or it is non-maskable interrupt. Okay, whenever it occurs, it has to be responded by the device. Okay, and next one is interrupt acknowledgement and interrupt response. So these are kind of interrupt where it will ask for acknowledgement. If you say yes, then only it would be activated, otherwise it will postpone. Okay, so these are non-maskable interrupt. INTR and INTA are non-maskable, just like we have a notification for restart. So if I'm free, then I can, and if I don't wish to restart, then I can postpone it. So this is non-maskable interrupt NMI, and another is maskable interrupt. So there is set of acknowledgement and responses. Okay, and then one more is, okay, let us go for this figure. So whenever you are dealing with this, you have to write whether it is in minimum mode or maximum mode. Whether it is minimum mode or maximum mode, very first thing, and they will ask you very clearly. Okay, so here I can write up to 1 to, here we have pin number 1 to 20. Okay, here we have 1, okay, so these are our number of pins. So very first pin we have to deal with is, what is basic requirement to run anything? We must have VCC, and another VCC, and here we can start our values from 21. Just a minute. It is 20. And here 21, then 22, okay, and so on. I'm not writing over here, otherwise it would take too much time. So just understand, we have here up to 40 or 42. Here we have 40 up to this one is 20, and then after we have 21 over here, 21 to 40 pins on the another end. Okay, so first 40 number pin, this 40 number pin is a voltage. For any of digital or electrical device or equipment, we must have some battery backup. Okay, or you should have voltage provider. So here we have provide VCC, voltage. Okay, so to manage this voltage, we must have here ground, G and D, ground. Okay, ground in the sense it will stop or it will deal with the it will deal with the extra or unwanted or leakage in any of voltage. So here I can write like this. We have two ground pins, G and D. Okay, first and last, 20 and first are ground pin, and 40 is our voltage supply. So very important, if you have voltage then only it can work. So first and last ground pin. Then over here we have next requirement, that is CLK, clock. Okay, first we provide voltage and we manage voltage by two ground pin. Okay, the next is clock at the 19th number. You can recall your friend having enrollment number 19. Okay, now next we have interrupt response, INT, interrupt and response. Okay, then after this response we have another non-maskable, NMI. See, we are talking about response, so where is the acknowledgement for this? Okay, it is in a pair, acknowledgement, interrupt acknowledgement and pair. So we of course have to set a pin for acknowledgement on the another end or at the right side. Here we have ground, then clock, then INTR, interrupt, response, and this is non-maskable interrupt. It won't ask for your permission. It will just execute it. Okay, so non-maskable. After the 16th bit, we have all real brothers or Judwa Bhais. Okay, they are having same functionality. They are AD0. It is AD0. Then next is AD1. So it will work as address bus, or you can write like this, address AD1. Fine. It can be address bus or it can be a data bus. So we have AD1, AD0 to here AD14, right? AD14 is over here. If you remember, we have, and at the 39, at pin number 39, we are having AD15. Okay, so our data address bus is of 20 bit and data would be of 16 bit. So here we have end of our data bus AD15, 0 to 15. Okay, then after at 38 bit we have one more. See, our address would be of 20 bit. So here it is A16. After 15 we have A16 and synchronized with some signal. Then in 37 we have address bus, that is A17, synchronized with some signal. Then 36. So again we have A18. Okay. Remember, we have to go up to 19. On this 35, at 35 pin, it would be A19. So it is end of our address bus required. A14 to AD0 to AD14 on left end, 16 to 2. And on the right end, we have our one data bus, address data bus, and 4 are address buses, A16 to A19. And we have synchronized signals over here are, here is S3, S4, S5 and S6. Okay, so these are the signaling. Then 30, after this 35, we have 34, and that is a BHE, bus high enable oblique S7, signal S7. So bus high enable, what does it mean? BHE or S7, bus high enables act as a odd memory. If you are using odd memory, then it would be positive. Okay, and it is synchronized with a signal. It shows that you are using odd memory. Okay. Then next is after BH7, we have 33, and it is very important. What is that? Mean and max mode. Okay, so if it is 0, then it is minimum mode, as it is maximum mode. And maximum mode in the sense we have multiple processor together. If we are dealing with a single processor, then it is minimum mode. Okay. Now at the 32 number, we have read instruction. Then 31. Now we have pair of two instruction. It is hold, HOLD hold, and next is 30. It is hold acknowledgement, HLDA. So when this particular hold and hold acknowledgement is used, hold. So whenever you are going for dynamic memory address, direct memory address, if you are going to use direct memory address, then this particular is used. Okay, hold means you are using that particular, and if you wanna use it, we have to send first the acknowledgement. If it is granted, then we can hold that particular address. Okay, and after hold and this we have write. So now we are going to read. Okay, so it is RD. First is write, WR, sorry, WR. Okay, so now we are going, first we read at the 32, and then 29 is write. Then after there is memory IO, whether you are dealing, this is 28, it is memory or IO, whether you are dealing with memory or IO devices. So after this 28, whether you are transferring data or you are receiving data, data transfer, DTR, 27 number is DTR, you are sending data or you are receiving data. Now at the 26 number we have DEN. Data enable. So data enable in the sense whenever the operation goes right. Pin is called when it goes low during the operation read. Okay, if it is 1, then data enable in the sense it is bar on this pin. Okay, there are bar on this pin. So if you are writing, then it will be 1. This pin is 1 if it is writing, and if it is reading, then it will be 1. 1 for W and 0 for read. Then at the 25th number, we are having ALE. So ALE will decide how pin number 2 to 16 and 39 to 35. Sorry, 35 to 39 pin will react. Okay, if it is if it is 1, then it has to be work like, if it is 1, then it will work as a address bus. It is 1, then it will work as address bus, and if it is 0, then data bus. Then next is interrupt enable, interrupt request. See, here we have response, so we have to use INTA, acknowledgement, because if there is acknowledgement, then only one can respond. So after that INTA, we have three pins, 22, 23 and 21. Okay, so what is about this pin 23? It will test the external device. Then next is ready, whether your device is ready to use or not. And next is reset. The last is reset. Whenever your operation is performed, we can reset it or we can retrieve the old values. Understand? AL is very important because pin number 1 to 16 and 35 to 39 are dependent on it. Okay, if AL is 0, then it will work as a data bus. So 38 to 34 will use as a signaling or for the signaling. And if it is 1, then it has to deal as a address bus. So all 1 to 16 and 39 to 35 to 39 will work as a address bus. Okay, quickly write down this. Then we have one last question from this chapter is segmentation or generating physical address using logical address. Quickly write down this and let me know. Should we finish it or not? So almost thing are given, but if you wanna write, you can write like this kind of short notes. So you can easily recall the point.